Hi, Kathy and Jeff back again. We're here to talk with you about Unit 7, Earth and Human Activity.
There are two standards, 5 ESS 3-1, which is obtain and combine information about ways communities reduce human impact on the Earth's resources and environment by changing an agricultural, industrial, or community practice or process.
And 5-ESS 3-2, test a simple system designed to filter particulates out of water and propose one change to the design to improve it. We will be utilizing both of these standards in this unit, as well as building off of Unit 3, which was water, water everywhere. And that's when the students looked at water systems, aquifers, and groundwater.
What are you talking about?
That's right, Jeff, water.
We're going to consider how humans can affect the Earth's water resource. Agriculture is the biggest user of global fresh water, with farming and livestock production using about 70% of Earth's surface water supplies.
Did you also know that farms and farming are also a major source of water pollution? In the United States, agricultural pollution is the top source of contamination in rivers and streams, and the second biggest source in wetlands, the third main source of water pollution in lakes. It's also a major contributor of contamination to estuaries and groundwater.
Every time it rains, fertilizers, pesticides, and animal waste from farms and livestock operation wash nutrients and pathogens such as bacteria and viruses into our waterways. Nutrient pollution caused by too much nitrogen and phosphorus in the water or air is the #1 threat to water quality worldwide and can cause an algae bloom, a toxic soup of blue-green algae that can be harmful to people and wildlife.
And used water is also a big polluter. It comes from our sinks, showers, and toilets, and from commercial, industrial, and agricultural activities. Stormwater runoff happens when rainfall carries things like road salt, oil, grease, and chemicals, and debris from roads and parking lots into our waterways. Did you know that more than 80% of the world's wastewater flows back into the environment without being treated? And that's according to the United Nations.
That's pretty bad. In the United States, wastewater treatment facilities process about 34 billion gallons of wastewater per day. Yikes! These facilities reduce the amount of pollutants before discharging the treated water back into the waterways. That's when everything goes well. But according to EPA estimates, our nation's aging and easily overwhelmed sewage treatment systems also release about 850 billion gallons of untreated water each year.
And that's not even considering oil spills. While they might dominate the news headlines, consumers, people like you and me, we account for most of the oil pollution in the seas. It comes from the oil and gasoline that drips from millions of cars and trucks every day. And nearly half of the estimated 1 million tons of oil that make its way into the marine environment comes not from tanker spills, but from land-based sources like factories, farms, and cities.
Now that we've totally bummed people out, there is some bright news. Let's get to our activity. It's called Get the Dirt Out and comes from a larger unit called Water Resources Student Activities for the Classroom, which is funded by the EPA. These activities are found on Atlas, and there's also a 5E example for this topic in the resource section of the unit on Atlas.
Now we know that all living things require clean water for survival. As we said earlier, humans add things to the water that pollutes it. Polluted water is bad for living things, makes them sick or even die. And it's best to keep water pollution from happening, but there are ways of removing some pollutants from the water.
The activity Get the Dirt Out is very simple. Students pour water into two plastic glasses, and they put one to the side. Then they add things like pencil shavings, paper strips, styrofoam peanuts, detergent, vinegar, whatever else you'd like to use in the other glass.
To make the polluted water.
Okay. Water. So I'm going to do just that now. And we're going to take a teaspoon of sand. I'm going to take a teaspoon of the potting soil. And we're going to
Measure out
some oil.
All right, so you've added the 20 milliliters of oil. Let's go ahead and now add some vinegar.
All right, I'm going to add the same amount.
So while Jeff's pouring out the vinegar, we want you to pay attention to vinegar is one of those solutions. You want to make sure that students are wearing their safety goggles. The fumes from the vinegar can be very irritating to their eyes. So he's going to measure out the 20 milliliters of vinegar and add that to our polluted water.
Okay, we've got it. And now we're going to stir up our polluted water.
I just want to be able to show everyone how, when you're mixing that polluted water, you want to make sure all of the mixture is really getting sloshed around there, okay?
All right. And now what we're going to do is we're going to take a coffee filter.
And we recommend the cone-shaped, like a number 2 fits perfect for these size cups.
And you can either have this taped to the cup, or you could have partners working where one partner is holding the coffee filter. Hey, partner, hold my coffee filter.
Give that one more stir before you pour it. Great. And pour slowly.
Looks pretty.
So you want to make sure as the clean or the filtered water is dripping down that your coffee filter doesn't sit in that liquid. Go ahead and pour.
I think our filter is working slowly.
All right, go ahead and pour in the rest.
I think so.
Right, and again, just make sure that the bottom of your filter paper stays out of the filtered liquid. So once everything's finished filtering, you want students to use a hand lens and be able to take a look at the clear water, the filtered water, and also the materials that were in their filter paper. Have them start to take a look, observe, and just record what they're seeing.
So they can discuss and write about the results of the experiment and use questions such as, does the water look clean? Does it feel clean? Does it smell clean? And these will assist in student thinking. When you're smelling the water, remember we put vinegar in, so we want to just put our nose over and waft the cup.
No direct smelling. So also make sure they're able to waft and smell the results that are in the filter paper. And what we find is that the vinegar is still in both the filtered water and the filter paper, which is telling me that we didn't filter out all of that smelly pollutant. So that becomes an open-ended question. What could you find a way or redesign this to be able to filter out that liquid?
We can also see the color is very different, so there are other things we need to try to filter out with the second version.
Good point. Another great option for this unit is to purchase a kit from the Boston Museum of Science, EIE, Engineering is Elementary program. If you Google EIE.org, you'll be able to see all of the different kits and resources available from Engineering is Elementary. We like this kit called Water, Water Everywhere, Designing Water Filters. If you purchased the kit, you would get a teacher's guide with information on how to conduct each of the lessons. You'd get a materials kit and a storybook. In this case, the story is about a young girl named Salila who has some turtles in a nearby pond that are being harmed by water pollution. She works with an engineer to learn how to design a water filtration system for this little pond to help to save her turtles.
Kathy, I have a question about all this.
Yeah, Jeff, go ahead.
If we can't see air, can fish see water?
Wow, that's a really good question, but I don't understand why that matters.
You're right. But we both know science matters.